What is memory architecture? Anyone? Based on yesterday's discussion, just want to
Uh,
do a little bit recap.
okay, so mainly the like IPC stuff, how exactly
Mhm,
things works in between
mhm,
at cache and process communication,
mhm.
and the impact of your caching buffer on the overall performance.
Right. And related to your process architecture, in case let me make little bit confusion so that you can answer it well. I have process architecture, I have memory architecture. And when I will start the replication, uh, let's suppose I have started the replication, master and slave replication in Postgre, normal replication. So what kind of process that will be appear in my process architecture? Any idea?
Yeah, the
Sender
sender
and
and
receiver.
receiver.
Abhishek,
Hmm.
can you start the recording?
Yeah, it is started. It's already started. So can someone answer?
The first one will be the connection from standby to primary, and then it
Hmm.
will be val receiver, val sender one. I mean, these
Hmm.
three one I'm aware of.
Hmm. Very good. So, but it will fall under which category? Process architecture, memory architecture.
So
Process
process
architecture.
architecture.
Yes.
Very good. That's what. So at least we are on the same page, everyone. Then it's fine. So let's understand few more important concept, and then we will go to the memory architecture. So in the memory architecture, we can break our architecture just for the understanding point of view. We can break into two pieces. Memory architecture we can break into two pieces called local memory area and shared memory area. Okay, so what is local memory area? The local memory area is allocated by each backend process by its own. So let me copy paste the existing architecture also here so that we can connect all the dots. If it is not visible for the people, just let me know. I will increase it a bit. Okay, so here, excuse me. So allocated by each under the backend process, here we have a backend process. Under each backend process, we are allocating some local memory area. Okay, I will talk to that in the detail in a few minutes, but just for now, just understand that you got a memory area which is backend memory area, and under that also it have its own local memory area. Okay, so these memory area is basically is reserved for backend process to work on the next database activity or database task. For now, just to make it simple inside your mind, you can think like background process also have little bit part of memory which is local memory area, and another part is shared memory area. So shared memory area is nothing but the the shared memory part is the part where it is getting shared by multiple processes. So what is the shared memory area in Postgre? This is the shared one, right? Which is getting shared by everyone or all the process basically.
Background
In
process.
other words, you can think like it is your SGA, the old one. The people who are from the uh, Oracle side, you
Oracle.
can think of it's a SGA. People who are from the MySQL, and they are, they are using InnoDB buffer pool. They can think like it's a InnoDB buffer pool. Mongo people, I think they can think like it's a white white tiger shared buffer or something like that, or shared buffer, something like that. Okay, a buffer which is shared between all the processes, and it have certain tasks which we are going to discuss to perform as a shared memory area. Shared means it is shared between multiple processes. Okay, so the understanding here that we have to build is backend process. It is just not a backend process. Again, backend process also have its local memory area, and on the other hand side we have shared memory area. Okay, so you can say this is local memory area, we have created some part here, and also we have shared memory area. Okay, so now let's think, let's understand what is the what is the what all the components that are building our local memory area. Okay, so basically in very very high level, I don't want to confuse you now, but later on we'll understand it more. We have temporary buffers. Okay, so in the backend, in your backend process, think like there is a small part, small part which is responsible for temp underscore buffers. So what is temp underscore buffer? Temp underscore buffer is a place where your query and your session level sorting operations happens, or you can say mathematical operation happens. Whenever you are using joins, order by, or something, wherever you have to parse some data and keep it for some time, or staging area also you can say, it's nothing but temp buffers. People who are from the Oracle side can understand, can think like it is dba underscore temp underscore files, right? We have that configuration, right, where we are storing the temporary buffer, or something in the file. And also we have v dollar temp or something, I don't remember that. In InnoDB buffer
Dynamic view.
we dynamic view, correct. So I'm just giving you an example that temporary, if you session level, if you have to hold anything, it goes under the backend process temp buffers. Okay, few concepts might interrelate related to the other databases. Few concepts are completely new in the Postgre. Okay, so temp buffer, okay, and work underscore mem. Okay, these two things are basically, temp is mainly used to restore the temporary tables, temporary data. Work underscore mem is basically used to execute the sorting tuples, order by, distinct operation, joining operations, merge a hash, whatever happens on the query level, that is handled by work underscore mem. And the very important part, which is maintenance underscore work underscore mem. Okay, so maintenance underscore work underscore mem is an area where you are performing lot of maintenance which is related to your DBA maintenance. In other words, you can say. So let's suppose you are running a very big vacuuming process, okay, which we'll discuss later, what is vacuuming and everything. So whenever you are running a vacuuming process and you think that this particular default size, every session or every server backend process gets a default maintenance underscore work underscore mem. Okay, so let's suppose you are creating a big index and you think that I have to create this index little bit faster. Okay, or in other words, you are running a big vacuuming process and you want that vacuum process to work little bit faster. So what you do in the session level itself, in the session level itself, you can give more memory or more buffer to this particular uh, option. And when you give more memory to maintenance underscore work underscore mem, your specific task is going to get more buffers. More buffers means it is going to be executed faster. Okay, so this is something new which is not there even in the Oracle or in other places. You can think like in Oracle or something that you are increasing your session level memory or session level buffer to execute the task faster, something like that. Okay, so in very uh, in a different world, let me correlate this that these three areas are residing under your backend process here. These three areas, which you can control on backend level. Okay. When we are going to do the production server planning session, we are going to talk about these three things very in depth. The reason is whenever you are ordering a new server or new VM or something, there is a small concept that you have to understand that how much memory, how much CPU you have to order based on certain calculation on your backend process. Okay, so this is another important thing that you have to understand. Now let's understand what is shared memory. Okay, so like other databases, like any other databases, you can think like your shared memory is divided into three parts. Okay, one is shared pool, another is wall buffer, and another one is commit log. Okay, so shared buffer pool is the heart of my Postgre database architecture, basically. So whenever you are starting your database or whenever your database is started and you are running any query, the temporarily those buffers which is going to be used by your queries are getting placed into shared buffer, same like Oracle. Okay, uh, you can in Postgre, if you want to understand it better, again the block in Postgre level, we don't call it blocks, we call it pages. So you can say, or you can think like your pages are going to be placed temporarily on shared buffer pool. If any changes happens, insert any DML, insert, update, delete, anything happens, and sessions or your session or transaction is committing that specific data, the change information goes to first commit happens. Before the commit, change information goes to your wall buffer. Okay, and once wall buffer is going to send you a signal saying that successfully page has been successfully written, your change block has been committed on your shared buffer pool. Okay, like that. And whenever you this commit is happening, the commit is going to create a commit log. Okay, and this commit log is nothing but transactional level commit or session level commit. Okay, in future we are going to understand the session level things also in detail, like session, transaction, and SQL. These three concepts we will understand in the connection pooling. So that time also I will correlate all these things with this architecture so that you understand it. So in a very high level, user has user has connected to Postgre database. The moment he connected to the Postgre database, a new backend process has been initiated for this specific client. Let's suppose this is the client, and under that specific background process, you got two kind of memory architecture, local and local is created here. Shared is already started by your postmaster process initially when you have started the database. Okay. In other words, you can say PGCTL, because initially all your database is started by PGCTL. Even if you see the process, right? Let me practically show you what I am talking about. Meanwhile, any question? Meanwhile, I'm starting this. Any question which is not clear or you are not sure about that? Anyone?
Abhishek,
Mhm.
I cannot see a postmaster process in this diagram.
Correct. So what I have in the initial discussion itself, when I was talking about when your Postgre is started, that is nothing but server process. This is your postmaster or server process, which has started your entire database. In other words, you can
Okay, sir.
call it postmaster process. Somewhere, I
Thank
think
you.
yesterday I have mentioned it. Let me show you also, okay, practically.
Yeah.
Let me start the instance, okay. Any other question? I'm fine if you ask the question again and again because it's a important concept. If you're not clear,
Abhishek, for me, one question.
Mhm.
That you have been explained on that, right? The shared buffer pool, the
Mhm.
changes will be moved to wall buffer,
Mhm.
and then it will go to the C log. Can you explain that?
Mhm. I'll tell you. So, how many of you understand the transactions, database transactions? Because that is more important. Or let me construct a transaction, small transaction. Let's suppose whenever we write the transaction, we start with the begin statement, right? Database transactions are not the bare transactions or raw transaction that we do. So that's what I was trying to explain you that, or let me explain it now itself. Okay. So let me interrelate all these things and then you will understand. So when a developer is writing any program, let's suppose he is writing a PGSQL block or in Oracle PL/SQL block, he starts his transaction under the begin statement, right? And under this begin statement, he's writing everything like insert, update, delete, all those things, right? So when the insert, these kind of transactions are happening on the database level, so let's suppose this shared buffer is having a limited space, right? It can't, let's suppose my database is 5 GB. My shared buffer size is default is just 32 MB, right? It can't hold the 5 GB data or table directly to the shared buffer, right? So the moment you execute the query, what happens? The pages which is related to this particular table will going to be placed here, right? For the faster execution, right? The pages will come here, right? The moment your transaction, this is your transaction, it's committed. It can be XYZ anything. The moment it is committed, commit data, your server process is not going to write or the other memory process is not going to write these pages directly to the data file, right? First, what it will do, it will capture the change information. So in Postgres language, we call it write ahead log. So before writing into the data file, what will happen? The write ahead log or buffer will be created for that. Okay. The moment it has created and wall buffer has sent a signal to shared buffer that it is successfully written, commit will happen. The moment commit will happen, your commit log will be generated and it will kept it for the future um, transactional log purpose. Is that clear?
Yeah, the thing is, we missed you for a minute, for a few seconds.
Aha,
Uh,
okay, okay.
um, Actually, once after the shared buffer pool, once the write ahead log will
Mhm,
send a signal, and then we
mhm.
lost you.
Okay, okay. Sorry. Uh, Normally when I ask this question, I get a lot of mixed answer and I get a little bit confused also. But let me talk about this also. Basically, this topic comes when I am teaching the connection pooling. So let's suppose you have an application and this is your database. Uh, this particular application is creating a communication between uh, application and database, right? This arrow is nothing but a communication. So technically, what is this arrow consist? Very high level. No, no, don't think like it's a Oracle, MySQL, anything. What is your core understanding? This pipe, let's suppose this is a pipe which is responsible to take the data from this end and give it to application, or take the instructions or command from application and send it to the database. So this pipe is consist of what? What is the core property of this pipe?
User authentication and authorization.
User authentication and auth. Okay, very high level. This is done. Okay, successfully. Second,
A process which is
process. Let's
Uh,
suppose process is initiated. Backend
is it,
process created.
the acknowledgement will be request response thing will be happen between them.
Correct. That is also happened. Request and response is done. What is the spectrum of this pipe? Do you understand the spectrum? Let's suppose this is my pipe. Under the pipe, I have multiple sections. Okay. So I'll talk here very briefly, but in the later sessions when we will understand about the connection pooling, PG buffer, PG bouncer, PG pool, all those things we'll understand. So basically, these pipes can be considered on 3 levels. Okay. These pipes can be work on the session level, where just a single session is getting initiated. It happens on the operating system also. When you do SSH to a server, these kind of thing happens and you are getting a session. Session is nothing but a kind of pipe between your server or database session. Okay.
Just a
Where
terminal, right?
just a terminal session has established, pipe has been created. Okay. But we don't know what is the consist of this pipe. And then another kind of transaction or another kind of pipe that get created, which is transaction level. So when I say transaction level, it is nothing but the database is going to handle it on asset profile based transactions. There my A comes into the picture. I will talk about asset and cap also very soon. So that is another one is transaction level. Then what is the third level? The third level is command or statement level. So command or statement level is nothing but you simply go to PSQL and you are simply giving some command /d or something, or you log into the Oracle and you are simply giving the command. So which is command level. Okay. So all these concept has to be understood when we are doing connection pooling. Then only we are able to create a very good solution for our application kind of environment. Okay, that we'll think of that we'll see in the later session. But for now, from here onwards, for us, this pipe is not only pipe. It has consist of multiple things. Either this pipe will be session level pipe, transaction level pipe, or command or statement level pipe. Okay, we'll discuss all these things in the detail when we will establish the connection pooling class or session, and we'll understand for which particular session, for which particular application we should choose which kind of connection pooling and what is the better one. Let's suppose if you are working for a payment gateway company, what is the best way of pooling the connection? If you are working for a normal OLTP database, or mixed database, what is the best way? So all thing we'll discuss. But for now, backend process, we did the little bit postmortem of that, and we found that backend process have its own memory, which we called as a local memory, and it also interacts with a Postgre architecture memory, which is shared memory. And shared memory again have 3 parts, very high level. We're not going to understand everything today. That's not the goal, but very high level. We have shared buffer pool, wall buffer pool, and commit log. That's all. Okay. Is this clear at least this high level? Because I'm going to connect all the dots step by step, at least for now.
Shared memory is, shareable across the instance. That cluster, specific
Cluster. Very good point. You brought a very good point. So again, just give me an answer. If I say shared memory, let's take, I'm taking his statement. Shared memory is shared between the cluster. So what does that mean? Does it mean that if I create a new database, I'll get a new shared memory?
No.
No.
No. So why no? Which shared memory will be used?
Existing.
Existing one. So in other words, just give me an answer like that. Is it shared memory relation is 101 or one to many?
One to many.
One to
One
many.
to many. Very good. So just think, put these kind of concepts in your mind that one to many, 101. If it is Oracle, yesterday we discussed, right? If it is
Yes.
Oracle,
One-on-one.
101.
Yeah, 1-on-1.
101. If it is MySQL,
One or many.
one to many. If it is MongoDB,
One to many.
one to many. Elasticsearch,
One to many.
one to many. So ClickHouse, one to many. TIDB, one to many. Okay. So all these things are important concepts you have to understand. Okay. Is this clear? Everyone just say yes or no, or I'm not clear.
Yes.
So everyone, right? Don't take it. Don't accept my words. Don't accept it. I'm like you only. If you have a single question, single doubt, we can have a good discussion here. Don't accept my words. Okay.
Abhishek,
Mm-hmm.
yeah, I have a question. Okay.
Mm-hmm.
Now let's suppose I have a server
Mm-hmm.
and the total RAM is 32 GB. Okay.
Mm-hmm.
Out of which I have given to my Postgres instance
Mm-hmm.
a shared buffer of 20 GB. Okay.
Mm-hmm.
So my question is, so we have
You
lot
have
of
30 GB. Out of
32
that,
GB of RAM, 32 GB
32
of
GB of
RAM.
RAM.
Okay.
Okay.
Out of which I have, let's suppose, given a 12 GB to my shared buffer.
Okay.
Okay.
Mm-hmm.
And rest all are remains for my OS.
Mm-hmm.
So till now, what my understanding is, so whatever the background process we have,
Mm-hmm.
background check pointer, auto vacuum, wall writer,
Mm-hmm.
stacks, log writer, archiver,
Mm-hmm.
even work mem, temp buffer, temporary memory, maintenance work mem, whatever. So all these parameter, all this component will take memory from the remaining 28 GB, or sorry,
Yeah.
yeah, the remaining OS memory, or
Mm.
will it take from the shared buffer, which is 12 GB,
Let me
or
answer it here.
is it like the 12 GB is remained
Mm.
only for the caching purpose, so that work mem, maintenance work mem, temp buffer, background, and all these processes
Mm.
will take the memory from the OS. They will not touch the shared buffer.
Let me create a small diagram, and which will give you a great idea to understand your question. Okay. First of all, let's think like this. Your question is how your 32 GB out of your 32 GB, let's suppose you have 32 GB of RAM, and in that you have given 12 GB to your shared buffer, right? The entire shared buffer and all, right? So the first
Yes.
thing is the shared memory is going to occupy this 12 GB, okay, and related all the components, okay. Whenever a client is connecting to the database, backend process is going to create another memory area, connection 1, which is out of this 12 GB, okay. And there are going to be another memory areas, which is, let's suppose if you are starting any other process, okay, which is consist of, which is, let's suppose just think like this is a group. So this is also going to take some part of your memory. So it is the combination of all these things. The more backend process are going to spin your server, the more memory is going to be used from remain 32 minus 12 minus this particular, sorry, minus this area, whatever area buffer and all we have decided. The remaining part let's think like this, 32 GB.
Max connection.
Correct. So here it is going for shared buffer, which is 12 GB. Some part is gone for this background process and all, some memory area, which we can control it very well in the Postgre. Remaining, whenever a backend process is getting connected, mean to say your session is getting connected, it will occupy your process from your RAM. And there's a very straightforward communication way, straightforward calculation, which you can, based on your connection method. Let's suppose you are using, your application is using Nginx or Tomcat or any XYZ application server, and it is connecting to your database. You can specifically count that how much single backend processes occupying in your server, like that. So it's a consist of multiple memory. It's not like that 12 GB you have given and the entire Postgre is going to use this 12 GB. No, there are multiple other processes. Every connection is going to span its own backend process, and backend processes consist of what? These three memory areas, right? Let's suppose if your query is doing a lot of order by a lot of join and all, then definitely your work underscore mem is going to increase, and this pipe size will get increase, like that. Make sense? Is this clear, Vikas?
So that means let's suppose I have a max connection limit to 100 only. Okay.
Correct. Correct.
So also we have a component of work memory,
Correct.
which is by default set to 4 MB.
Correct.
So let's suppose if at this point of time all my 100 connection is reached, okay,
Correct.
that means 4 MB into 100, that much of MB will be occupied for my OS from my OS memory, or is it like from, let's suppose, from a single connection there is a multiple sorting and hashing. Let's suppose in a single select query there are, let's suppose, 4 sorting and hashing. That means 4 into 4, 16 MB of RAM from OS will be occupied for that one single connection.
No, every
How is it?
single connection has its own work underscore mem. So it will happen on its own backend process level. They are not interrelated. It's not like MySQL or Oracle, where you have threads, mean to say single connection, and multiple threads are working under that. No, it is completely separate process. Backend process is separate process. It has its own memory area, work underscore mem, or maintenance work underscore mem and 10 buffer. So it will happen in that particular pipe or that particular session. They are not interrelated. So memory calculation is going to happen on each backend process, not as a combination. Okay, so let's suppose you have 400 connections and a single backend process is using 1 MB, then definitely it is going to take 400 MB on that. That's why I have created a separate session for production planning, because it's not like that we are just say 400 MB and we will buy a new server with the RAM of 400, which can accommodate this much space. Not like that. There are multiple other factors that we are going to see when we are doing the planning. But you got your answer at least.
Yes, Abhishek. So what I commonly see, so most of the DBA think like the more work mem we will give, the better the performance we will get. The
No,
more
that's
shared
not
buffer we will give,
yeah.
the better the performance we get. But they
No.
don't think this way, that if a connection got increased, the work memory will also, take the
Yes,
memory.
yes. That's why
So
when I have started the architecture, I told we are not going to read the architecture traditionally, where I will just come up with a slide and I will say this is shared buffer pool, that is that and all. No, the more you understand about these kind of concept, right? Your connection has for a normal DBA, they think connection is just a connection. But what we are going to do, we are going to the postmortem of this connection, and we'll try to understand it. Every connection have its own underneath spectrums or dividation. Okay, so in other words, in the same pipe, let's suppose this is the pipe. In the same pipe, I have cold water I have hot water, and I have lukewarm water. So we have to understand what are these segregations are, and in future how we can tune it, how we can understand in a such a way so that we can provide a better solution to any application. But you are right, everyone thinks like that, but it's not the case. And that's why whenever people are doing performance tuning or session level tuning, they take wrong decisions, or they are believing or depending on the chat GPT or something, but they doesn't understand the architecture, or they don't know how to ask the right question to the Google or chat GPT. So that's what I'm trying to do here, so that your this architecture and the memory area, everything is very clear inside your mind. I don't want you to go and do a lot of in-depth knowledge and all. No, at this point, no. Just understand who is who and who is what and what they are doing. Okay, and based on that, we will develop our knowledge layer by layer like onion, and we'll connect all the dots. Vikas, you're clear? Oh, is it good?
Yes,
Like,
okay.
yes. So now let's suppose our process architecture and memory architecture is ready. Okay, and we had this discussion also. Okay, so just give me few things like which I want to understand. Who will start my Postgre database? Who started? Who has started my
Postmaster,
Postgre? Postmaster. In other words, who what we call it?
any TV?
Mm, from the architecture point of view.
Process instance.
Instance.
Server process.
Server process.
Server process. I'm asking this question again and again because these kind of thing will happen in the interview. They will grill you a lot here and there. A lot of confusion will be made. And like Vikas was asking a question, I have a Java application, and under the Java application, I have 5 transactions running. Okay, very classical question asked in one of the very famous search engine interview. I have a Java application, and this is my database. Java application is going to run multiple statements. Again, whenever I'm asking this kind of question, the counter question should come: statement, transaction, or command. Okay, so I'm specifically telling transactions is coming from a Java application to my database. How many backend process I am going to get this kind of scenario? Let's suppose my transactions are 5 transactions I'm sending to my database. How many backend process I will get on the database?
One.
Okay,
For a
I'm just
single
giving.
connection,
Mhm,
so in a single connection, you are sending 5 transactions,
mhm,
or for
mhm.
5 transactions, you are connecting 5 times.
I have very specifically said Java application connecting to database. Under the Java application, I'm sending 5 transactions. Again, I have distinguished my words: session, transaction, SQL. So I'm telling transaction. I'm sending 5 transactions.
I think it will be in a single session. One connection will be made.
Okay, so the post break, people do Googling whatever they want to do and give me the answer. Okay, we'll take a break, 15 minutes break, and just give me the answer. Okay, this is little bit ambiguity is also there on the left hand side, but just give me the answer so that I will understand your overall concept. Okay, so Java application, 5 transactions, Postgre database. How many backend process will span? Or if you want to explain more that what happened, I'm fine with that also. Okay, so let's take 15-minute break. Today I'm not feeling well also, so I'm just I'm taking the break 7 minutes early. So
No
I hope
problem.
you people are not minding it. Okay, so let's
Please
back
stop
in
the
15
recording
minutes.
and
Yeah,
stop the
yeah,
timer, Abhishek. Thank
yeah,
you.
sure. Hello, everyone. You can hear me?
Yeah, Abhishek.
Yeah. So I was reading the answer. So all the answers are correct. And it doesn't matter how many transactions you are running. It matters that what kind of session you have established with the database. So the second answer is also good. If I have uh, two separate connections, so I will get two background process. Okay. So these kind of questions gives a lot of value when you are doing connection pooling, when you are understanding your application and you're designing the database architecture. Because if that clarity you have, that kind of vision you have, you can order a better database server. You can decide better database server. Let's suppose mainly it happens when you are ordering the server, physical server or virtual machine you are designing, or in the AWS you are designing your instance type in RDS. In other words, same thing goes to Azure and GCP. So that's why I was asking these kind of questions. Okay. Everyone clear? Is it good? We can go ahead or want to have more discussions?
And every post process we want memory, right? Means also
Right.
requires.
Sorry, what is the last part of your question?
For every postmaster process also requires memory. That's what I'm asking.
Yes. So that postmaster process memory is consist of your entire Postgre database instance basically.
Okay.
It's not something separate. It is inside with your Postgre server process. So sorry, instance, the overall
Okay.
instance. Yeah. Okay. So now let's understand few things. Currently, we are not going to give much, details in that, but we are just going to understand that. And when we are doing the query performance tuning and all, we'll go more into the depth of these kind of thing. But for now, let's understand the another concept called query processing. Okay, because that is another important. Oh God, my pen, something is wrong with this. 1 second. I have not stopped the recording, so sorry. Today you might see a long file. So query processing. Okay, before we go for the query processing, I want to give one traditional example that I give always to the people, which give you a lot of understanding about query processing, parsing, analyzing, rewriting, and statistics gather. Okay, so we all are using Google Maps, right? So let's suppose we are using Google Map and every day I travel from A location to B location. When I travel from A location to B location, it takes.
Abhishek, your screen is shared. Sorry, your screen is not shared.
I'm sorry. Okay. So query
Abhishek,
processing.
please start the recordings.
Yeah, it is already started. I forgot to, stop it. So
No problem.
it's already, but you might see a long file this time. Okay.
No
So
problem.
I was talking about the query processing. Whenever I talk about the query processing, I give some traditional examples, which is going to give you a lot of understanding about the query processing. So before we start with the query processing, there are certain words that we have to understand. Okay. So there are words called stats, which we are going to use again and again. We are going to use the word called parser or parsing. We are going to use the words like analyze. We are going to use the word called plan. Let's understand all these things in the step-by-step approach. But before that, just understand my example. Every day, let's suppose you are in a city like Bangalore, Pune, Hyderabad, or multiple places. You travel from A location to B location every day. So when you go to A to B, normally what you do, you use Google Map. Okay. So Google Map is showing you the best path. You travel A to B in 30 minutes, and Google shows you this particular path where you are saving your time and travel time and everything. In this road, what happened recently? They have constructed a overbridge. Okay, this overbridge got constructed, and now technically, if I see the same path, my travel supposed to be 15 minutes, but my Google map is not updated. What will happen if I'm traveling from A to B and my Google map is not updated with this new update that there's a new flyover constructed in between? What will happen?
You will not get correct routing. I mean, way.
Correct time. Still, I'm spending 30 minutes of my life every day on the road. Okay. And Google Map is not getting this flyover properly, placed in the Google Map. So basically, I'm losing 15 minutes every day. Okay. Let's understand this in the database level. This is your database. Google Map is your database, and this is your statistics, stats. So Google Map is taking its own statistics, which is there inside his mind, which says, boss, 30-minute best route. But this specific update or development is not updated inside his mind. So what is happening? I'm unnecessarily losing 15 minutes every day. But if I have an option, I can go and say, boss, Google, under my day-to-day commute or travel, there is a point, A1 and A2 got new flyover. If I update in Google's mind, what will happen? What will happen?
Travel time will be reduced.
Travel time will be reduced. It will be 15 minutes because Google knows this flyover or something different path, and it will. Okay. So now let's understand these all concept from the database point of view. So your Google Map is nothing but your database. Under the database, it is nothing but your SQL execution. Okay, and SQL execution always works based on the data, which data is nothing but your metadata or statistics. So these statistics are coming from where? Your catalog tables. What are the catalog tables? Your underneath database tables, which got created when you are installing the Postgre, the system table spaces or the underneath table spaces, which is actually capturing the metadata about your database. Okay. So your query is getting executed. This is my query. This query takes 30 minutes every day to execute. And but recently what happened? My table got index, and this information is missing. Okay, in my execution, then what will happen? My table is going to be executed again and again for 30 minutes, right? The moment I'll say my executor or my database, boss, I have index also available. What will happen? My query will start using index, right? And my overall execution time will be saved.
Reduce.
So these kind of information, what we call it, these kind of information, small information is nothing but stats. And who is collecting all these stats?
Optimizer in
Collector.
Oracle.
No,
Stats
we will not go into that level now, but just step by step, stats collector.
That's right.
So stats collector is a drone, which is every day goes to my city and it's taking the photographs. Based on the algorithm, it is setting all these kind of information where a flyover is built and all those things, and it's updating my Google map.
And
using, yeah.
Okay. And from 15th version, stats collector is deprecated, right?
No, we are not going it. Yeah, it is deprecated, but still we are just talking about some common terminology to understand the query processing.
Okay.
What is stats? What is plan? What is parser? All those things. Before I go take you to into the real query processing. Otherwise, I am going to use a lot of jargons or the words which you will not able to understand, right? And you will not able to refer what I am talking about. So currently, after this example, at least you know, right? What is stats? Everyone, what is the stats? So stats are the small information available inside the catalog tables or the catalog views, which tells me about my database. In other words, right?
Correct.
First concept cleared. Second thing, your A to B execution or A to B, whenever you go to home to office, there's a specific execution happens, right? It's like every day you take your car, bicycle, or by walk, right? First step, right? Second step, you just start your car, check your petrol, charge your mobile, connect your headphones, something you do, right? Process second. Process third, you start your car, you take first you take straight, then you take left, you take right, then you wait for the green light, orange light, all those things happens, right? All these processes happening, right? To what we are going to achieve, we are going trying to achieve to commute from point A to point B. So in a very high level, in a very outer side of this example, this particular whatever you are doing as a process or as a activities or group of activities is nothing but execution plan, right? Right? Can we consider it as an execution plan that you're executing something, your plan? What is your plan? Your plan is going to office. And as part of going to the office, this is my first plan to reach to the office. And under that execution plan, I have multiple nested tasks, right? Yes or no, everyone? Is this clear execution plan at least? That we have certain activities that I am performing to go from A location to B location. Okay. If anything, any component, any nested job, any activity is not performed well, will I able to execute my explain plan properly?
No.
Yes or no?
No.
No, right? Because let's suppose I have car and my car does not have proper fueling, or my car is not properly charged today. Yesterday I forgot to start the charging process. Then what will happen? I will not able to reach to my destination properly. So what kind of system I can inbuild that my car is charged properly? What is the modern system I can inbuild that it should tell me, boss, your car is not charged, tomorrow you have office, you will not able to reach on time? What we can do, every electronic car have the app or Bluetooth. So whenever we configure all those kind of thing, it sends a message or it sends an email, it sends a WhatsApp message. Your car is like 20%, have 20% battery, please charge it, right? All these kind of things happens, right? So basically what I'm trying to explain here is these kind of things, the small activity that you are performing to execute a plan is nothing but your execution plan. Okay. And the execution is going to happen on the real-time databases. Okay. So when your query is performing, basically it is nothing but selecting the data from the table, selecting the data from the indexes, and it is getting executed on the database. Okay. So some common concepts that we have to understand when we are reading about query performance tuning is stats, parser, analyzer, rewriter, planner, and executor. All those things we have to understand properly. That's why I've given you this example so that my next topic will be very clear for you to understand. Okay. So now let's understand the next topic. Some basics are clear, right? At least now some basics are clear, right? About stats, execution plan and all those things. So now let me take your knowledge to the next level. So this part we are clear, right? This part. Are we clear with this part? We have just talked about
Yeah.
it. This part. We have just talked about it, right? With our example. So my Java application has been started. My Java process has started. It has occupied a backend process. Now, what will happen next to execute my transaction on the database level? Okay. Let's not understand everything today. That is not the expectation. But in a very, very high level, let's understand what is happening inside and how it is getting processed. Okay. What is the first step? Parser. With your existing database knowledge, what is parsing? Anyone? What is
Hard parse
parsing?
or soft parse.
Hard
I
parse and
mean,
soft parse.
it
That is
is
a
it is
Oracle.
in memory. Yeah, it is in
Mhm.
memory, or either it is going to the physical data dictionary, fetching
Very
the
good.
data.
Fetching the data. What is the core purpose of parsing?
As far as I know,
Build the
it breaks
execution
the
plan.
query. It breaks the query and make a parse tree, na?
Parse tree. Very good. It breaks the query in creating the parse tree. What is the meaning of parse?
Like it checks whether the query is synthetically correct or semantic or syntactic
Mm.
correction.
Mhm.
Then when we write a query, the hierarchy
Mhm.
of query, like first it will check from, then condition, then column, then select. Likewise,
Correct.
I'm not
Correct. So the English definition of parsing is breaking something into the pieces or analyzing something or creating further paths. Okay. So in other words, these kind of things, if you want to read, I have recently shared one uh, website also. Let me reopen it because these kind of concepts are going to be important when we are reading about all these things in depth. Okay. So whenever you have time, go to this website, try to understand these concepts: array, sorting, bit mask, linked list, binary heap. So these are small concept. Sometimes in big companies, in their first round itself, they try to understand your understanding about these concepts. And these concepts are important when you are doing the query tuning. At least you understand on what basis your data is getting selected from your database. When I say sorting, so my expectation is the moment I say sorting, you should be very clear in your mind that I am talking about some kind of data retrieval or I am trying to get the data array, all those things. Okay, just an extra piece of information. Try to read about all these things. Okay, so parsing is nothing but breaking the data into multiple pieces or constructing something. Okay, so in the concept of database, basically we are creating a execution tree. Okay, so with my example of going office, what could be related to this? What you are doing basically, if I'm creating a parsing tree for my office going, what I will do? It's a basic, like very high level basic thing.
Shortest path.
What is that?
Shortest path.
Shortest path. Second thing, shortest path, time,
less cost.
less cost. Okay. All these things are important, right? So basically, when you are creating a parsing tree, you are trying to understand that how I am going to break this overall query or query execution into the smallest unit, and we can get a plan. Okay. So once you have these kind of plan ready, what is the next task that we have to perform? What is the next task? So the next task is
Execution, explain plan.
explain plan. So your query execution is ready, but in other words, that query is practically possible or not to execute on the database. Let's suppose I have a program written in C and C++ or Python inside my database, saying that how my query is going to execute. So the basic plan is ready. He said, okay, from A to B location, you can go, you just called your friend and asked like, today I'm new to Bangalore and I want to go from JP Nagar to Whitefield. I'm new to Hyderabad. I want to go from a specific location to Cyber City. I'm new to the Chennai. I want to go to Sahu Carpet. So what he did, or I'm new to the Pune. I want to go to Hinjewadi. So what he said, approximately it will take 50 minutes for you to go from this location to that location. And you will be like, okay, you got some idea. Okay, I have 50 minutes, 50 minutes to reach there. But actual execution is different rather than creating a plan, right? Everyone agree with that? I have a
Yes.
plan ready, but actually how it is going to be executed on the database, that is not ready. So what I am going to do, I'm going to run a semantic analysis on my parsing tree. Okay. Also, I'm going to analyze that this particular plan is actually doable or not, in the other words. Okay. And once that particular thing is ready, I'm going to go for the next step called rewriter. Okay. And rewriter will realize your query, or it will see your query tree. First, we have created the parse tree. Okay. And then we have created a query tree. Parse tree is just was the metadata available that we have read, and we created a execution idea, which I have called to my friend and got the idea. 50 minutes it will take. But actual execution, that I will go from car, from by walk, by aeroplane, is going to be decided in your query tree. And again, query tree is just only the execution of your query. It is not executed. It is not completed yet. So that particular query tree, how it is going to perform in your database, will be decided by your system rules. Okay. So system rules are nothing but set of rules, set of systems. In every database, these things are there. Either they will be rule based or they will be stats based. Okay. So a rule based means there is a rule, specific rule. Boss, I want to go from A location to B location. There is a rule. There is a road. I have to simply walk and go to my office. I can't do anything. There is a rule. There is a road. But if it is a statistics based or cost based, then what I will do further analysis of my execution, and I will see that for to go from A to B point, what will be the optimum path or optimum, in other words, a pipe or execution which is available to reach from that one place to another place. So how we are going to get these kind of statistics or the information, that I have to not go by this rule based, I have to use the cost based. How we get all these details? From which way? In Postgre? From catalog tables, right?
Yeah.
Catalog tables are getting your actual data about your database. Okay. And then finally, it is going to planner and executor. Basically, planner and executor are two different components. Once your planner is receiving the query tree, it is generating an actual query It's like which particular part is going for the short operation, which particular part is going for sequential scan, which will part will go for the, full scan. All those things are going to be ready in your planner phase. The moment your planner tree is ready, everything is ready, it will go and execute. Executor will take simply your query, and it will execute your query to the database. Okay. One interview question that people might ask in the future: in which stage I get explain plan? In which stage? Let's suppose 1, 2, 3, 4, 5. In which stage I will get actual exact explain plan? Try to find the answer. It's a very famous interview question. In which stage?
Planner.
Very good. Planner stage, you are going to get your actual execution plan. In the planner stage itself, you will come to know which kind of operations are going to happen in your query, whether it is sequential scan, full scan, or all those things. Okay. What is the difference between parsing tree and query tree? Very famous question. Note it down and give me the answer once in the next class.
Parsing tree.
Parsing tree versus query tree. Difference between parse tree versus query tree. These kind of question might be asked when they try to understand your knowledge. Okay. Let's suppose my query is inbuilt. It's on the fly. It is running, and side by side, one of my junior DBA is running stats for a table. 9:30, I have started a query, 9:30 a.m. In 9:30 a.m. itself, my junior DBA is running gather stats, or he has started capturing the statistics. Will this operation, let's call it operation A, this is called operation B. Do you think my operation B is going to impact operation A? Mean to say, my office journey is already started from A to B, and meanwhile Google Map is getting updated with this flyover information. What will
No.
happen?
No, it will go with the old execution.
Very good. Can someone explain me why? Why it is not going to?
Because statistic not, updated.
Very
It's
good.
Up to
still.
date. Up to
Very
date.
good. So, but I am already started my journey, right? I am still 500-meter away from the bridge, from flyover. Still, it will not update.
No, it will not update. Optimizer will not take for the
Very good.
latest stats.
Because you already get the route path from the map.
Yeah.
Very
And,
good.
and you
Very
already
good answer.
choose.
Very good. So at least you people are clear. And this is I'm going to my office, and now my friend is going to start after 15 minutes. What will happen?
They will get it.
You will get the new update.
Yes. New
Very
updates.
good. New updates. How I can influence this kind of executions? Mean to say, my friend is getting, I'm getting, and there is another execution going to happen. So how optimizer and everything is going to handle these stats? How they get the updates? No
They will
problem.
reuse
You
the,
take.
they will reuse the previous one. If
Very
there is.
good. Can you explain it so that other will also understand? It's very good. They will?
Yeah, so in DB2, yeah, there is a package cache is there. So whenever a new execution comes, it will take the explain plan from the package cache and it will execute.
Correct.
I mean, yeah.
Same thing goes here also. There is a previous execution plan available, which is more optimized, have more current status. So automatically the new executions are going to follow that. In Oracle, we have multiple ways. Oracle is a very mature database, there also I can control these kind of thing. Nagesh, I think you must be knowing about that, right? We can control the old execution. How we can control that? Just short
You
answer.
can use
Like,
int. In Oracle, you can use int.
very good. Any other way?
SQL based plan also you can create in Oracle.
SQL based plan also you can create. You can create profiles also, right?
Profile also, short-term
Right.
profile, and
Short-term
SQL based
profile.
longer term.
Yes, because my friend, he want to listen the song and he don't want to go with the shorter path. He want to go with 30 minutes. He want to finish 2 songs while going to office. He's not bothered about your plan and everything.
Either way we can do, yeah.
Yes, yes. So why I'm asking all these questions, you will might grilled, you might get, people might confuse you again and again to understand your knowledge about all these kind of concepts. So the core concept remains same. Statistics, execution, parsing, planning, and execution. Okay. All those things are very important. Make sense? Everyone?
Yes.
Second thing, when we will do the monitoring and database monitoring and other stuff, what we will do, we are going to use some third-party tools also, okay, where we will see all these kind of execution on the screen so that I can show you everything. Okay. So now our example is clear. A person has driven from A place to B place. We have used flyover, we have not used flyover. We have used all kind of concepts to understand the overall execution. We have also understand the client part. Okay. There's a small addition. When we will talk about the connection pooling, we might get a different kind of concept. Okay. So when I will teach you the connection pooling method, I'm going to give you a different concept altogether. Not different, but interrelated concept. So you have to understand that particular part also in your understanding or in your concepts. Okay, make sense, everyone? Any question before I go ahead? Anything which comes under your mind? Anything which comes under your mind? Can I go ahead? I'm not going to take much of your time. I will just cover one small concept, or if time will not permit, we'll take it to the next class. But is this clear at least, all these things?
Yes.
Now, very, very important concept, which we always skip it or we never pay attention. But that concept is going to take you from your current DBA role to architect level. 2 concepts, which I personally believe that every DBA should understand very carefully, and they should understand about these concepts in a such a way so that they can design the solutions. Okay. The first thing is ACID. What do you mean by ACID properties in the database? It's a concept taught in the BTech, BE, MCA, BCA, even in class 9th and 10th also in some boards they are talking about all these things when they teach about Python. So what is ACID? Short answer. I don't want anything, just a very high level. What do you understand about ACID or ACID enabled databases or ACID compliance are not following in this particular database? What do you mean by that?
Relational databases should
Relational
follow
database
ACID property.
or ACID property. So what does what is the mean of that statement that it should follow the ACID properties?
Atomicity, consistency, isolation, and durability.
Durability.
It means
So it
guarantee
must
of
follow.
reliable transaction.
Okay, so can someone explain me one by one A, C, and I and D step by step, or some?
Yeah, atomicity, consistency, durability, and isolation.
Mhm.
This way we can. So it's like everything is like atomicity. Like it's like RDBMS rule follow up that one everywhere. Like
Mhm.
uh, that we can say.
Mhm. Okay. Consistency. I'll explain more one more time with all the details, but this is very important from the interview point of view. This is very important from the
Uh,
architecture point of view.
yeah,
After and
atomicity
before
in the sense.
transaction,
Mhm. After and before transactions, what is the next?
transaction should be consistent.
Okay. Can you
It
put more light on the
it
consistent
will
part?
follow the rules. It will follow the rules, correct? Like in databases, we follow the constraint.
Hmm. Very good. Okay.
It will move from one valid state to other valid state.
Very good. When you say state, what do you mean?
The consistent points.
Consistent point. So that points are nothing but employee salary equal to 20 rupees from employee salary to 21 rupees, right? Let me be
Yeah.
very specific what he is trying to refer. Point, different points. Isolation.
Read and write should not interfere each other.
Correct. If I am talking to my database, it should be private because I might be talking about credit card. I might be talking about the financial things to my database. I don't want anyone to hear that transaction, that communication. I want it to be very perfect, isolated, and also I don't want my transaction to seen by other process. Durability.
It is
Data
permanent.
permanent. It
Okay.
should be in the wall.
Okay. Little more explanation.
If the system crashes, the result
Mhm.
should stay permanent.
Very good. Very good. So system should be by any chance hook or crook, disaster or a very beautiful day, my database has to be there. It has to be given me the data which was written or committed in the previous transactions. Simple, right? This is going to give
Yes.
me a guarantee that my database never ever going to be lost by any mean. I'm not bothered about whether my wall segments are there or not. Being a user, I want my data to be back because let's suppose I'm a bank. I want that my database to be back. So atomicity, let me explain it a bit with the example. I'm running a transaction. Again, mark my words. I am running a transaction. Am I running a session? Am I running a command or I am running a transaction? So mark my words. I am running a transaction. When I say I'm running a transaction, I will start my transaction with begin and end and begin and commit. Very, very carefully. Okay. These questions might get, you know, will go into the layer of onion and might come back again in the interviews. So that's why I'm telling you again and again. I'm running a transaction. Either all the task under my transaction will be committed or will be rollback. I have in the begin statement, I have multiple transaction, insert, update, delete, and again insert. If any point of time, any execution fails, let's suppose third number is failed, my entire transaction will go back to zero. That kind of guarantee is nothing but atomicity. Either all or either none will be committed to my database if I'm running a transaction. So that kind of guarantee A gives me from the database. Consistency means if A is running a transaction and B is running the transaction, they should see the consistent image of the data. If C is updated +1, the D is supposed to see the 11 rupees. So that kind of consistency is important in my database. If consistency is not there, then there are different kind of issues might happen. Okay. In the performance tuning section, we are going to read about phantom reads um, and different type of these kind of concepts, which is commonly comes into the databases. Isolation. Current transaction should not see the other transactions value or the details. Durability. Once your database is saved, written, it should not, it should not, it should not. What is that durability means? It should not be lost.
Lost.
Okay.
It is preserved in the database.
It is preserved in the database by any means. I should be retrieving it. Okay. Now let's understand about one more concept, which is cap. Okay. And later on, I will give you the dots, how you can interpret all these things. Okay. And I will ask some questions also. In cap, C stands for consistency. A stands for availability and P stands for partition tolerance. Anyone understand about that? CAP, cap. Anyone understand about CAP?
This is for use for, I mean, open source database, right? This cap
No.
theorem.
Cap is a theorem. I will tell you why we use it. Consistency.
Abhishek,
Yeah.
in Oracle, that
Mhm.
consistency, if we have like a 2-node rack, it means that all the nodes must receive the same set of data.
Correct. Same set of data. If a transaction is getting executed, he should see the snapshot of same set of data from any node. Because your database is logically distributed into multiple nodes. Clear?
Yeah.
Is that the question? Yeah.
Yes, yes.
Okay. But let's suppose if it is a sharded cluster, will my database is equally distributed in all the nodes? No.
No, I guess.
No, it is not equally not distributed. We'll talk about sharding also in the future sessions so that your concepts are very clear when you're designing a system. Okay, cap theorem, quickly. Can someone explain one by one like acid, cap? Then I will tell you why I'm talking about all these things.
Consistency, availability,
Consistency,
Mhm.
partition
and
tolerance.
So C stands for consistency. Just quickly tell me why what is this in the terms of cap?
read returns the latest committed data.
Very good. Clients see the can see the stats or data, and they can get the data. Availability.
If in
It's in
cluster one of the node is, I mean, down, but still it can able to read from another node. It's availability.
Very good. Partition tolerance.
I mean, communication failures between nodes are tolerated. I mean, system continues to work.
Even
there
my
is any-
systems, even my nodes are discontinued from each other. My system should be performing well without any issues. Okay. Concept clear, everyone? Now, with this example, you will get more understanding. We all are a group of architects, and I am planning platform like Netflix. With the help of CAP, can someone tell me which database I will choose? Let me make it more clear. This is to showing my content, and this is for my billing. And also I have a comment system. After every movie, there is a below side, there is a section called comments. Okay. Now using CAP, everyone one by one suggest me for my content showing, for my movies and content showing to my user, which database I should choose.
Mongo.
Just Mongo. Why you drive to the Mongo, or what? Why you decided Mongo? Or let me bring this photograph first.
So as far as I know, so whatever RDBMS databases are available in market, they don't support cap theorem. They only support ACID. So Mongo is something I think that falls under cap.
Which
So
CAP
even
also is divided into multiple pieces. CA,
Yeah.
CP, and AP.
So it's like a system designing concept. So at any point of time, we can achieve only two state,
Two
either
states.
consistency or availability,
Mm.
or availability or a partition, or consistency or a partition.
Correct.
So
It is
we
very
don't have
rare
any
to
database.
find all which,
Yeah,
yeah. You can
it
complete your
falls
statement.
under all the all the brackets.
All the brackets. So I'm showing the content or movies to my customers. Customers are really interested in consistency. Are they really bothered about the consistency? They are not
No,
bothered about the consistency. They are bothered about what?
Availability.
Availability.
Availability. So when I'm making my content system or I'm choosing a database, what is the best database that I can choose? Cassandra. Couchbase. Where I'm not at all bothered about. Even my customer is seeing the movie after once they open their website or their application, even after 15 minutes, if they are seeing my new release movie, I'm not bothered. It's not going to make anyone's life miserable, right? But if I'm making a system for commenting system where I want to see what people are commenting on my movie, they say movie is good, bad, 3-star, 4-star, 5-star, something like that. Which kind of thing I should choose? Because these comments are going to impact
CA.
my content.
CA. I mean consistency and
Consistency.
availability.
I think according to me, this will be CP. Because here I was not bothered about much about timing and other thing, but here I am bothered because if my new movie is releasing and I can see more comments, people might see my content more. Okay, so CP, MongoDB is going to be a best option because I can see the comments. Based on the comments, I can promote my content. You can also use CA, but it's unnecessary, because even if one person is writing comment, I don't want other people to see that, right? I don't need that consistency. Yes or no?
Correct.
Even my comment is released after a few seconds. If they see, it's fine. I don't have any problem, right? Another important thing, why I'm taking CP for these kind of commenting system. Anyone? Let's suppose my comment system is running and suddenly there is a break or something happens to my system. But the commenting system is very important to promote my content in the Netflix. The new movie is released and I want my people or my viewer to see the comment itself, which is very important to promote my movie. If I will get more positive reviews, I can promote my content or people might see it more, right? So this is important aspect of my application. So that's why I want to achieve what I want to achieve. Partition tolerance also I want
Consistency.
to.
Yeah, partition
Consistency
tolerance.
and partition tolerance is more important for me. Okay.
Mhm.
Some people might say AP also. Yes, I'm fine with AP and CP. You can put it. Even you can put it in CA also. But according to me, availability or partition tolerance or consistency might not that relevant in this case. But at least if I can get the consistent reviews one by one after that, even if it is coming late, I'm fine with that. Now let's come to the very important part, which is the heart of my application. Billing. Which database should I choose?
CA.
CA. And what made you to think like that? Why we should
Because
use
it
CA?
is consistent and available.
Okay. So what you are achieving with consistency here?
Uh, able to read and available if any node also failure, it is available to user
Mm-hmm.
because user can able to pay the bills.
Very good.
That is also important.
That is very important. And I want my user to pay the bill and immediately his services are resumed, right? Or
Correct.
activated,
Yes.
which I
Right.
can achieve by consistency. If my
Yeah.
system is not consistent, it means if it is taking some time or it is not actively available, then I might lose the billing, right?
Correct. Correct.
Availability is very important because if my billing system is not available, I'm losing money, and then why I have started Netflix? End of the story. Business
Correct.
money runs business. Business runs technology. Technology never runs business. This is very important concept when you are architecting a
Yes.
system. We all are here because we are getting money from some technical company or software company. Even though if I know very good software, very good everything, if I'm not contribute to my business, I don't have any meaning in the system. Yes or no?
Absolutely right.
Even though I am a biggest doctor, I did PhD, CHD, whatever A to Z, whatever I did. If I'm not able to fix anyone's life, disease problem, there's no meaning of that, right? So same thing, technology has to serve business. If business is not making money, then there's no point of doing all these hard work or things. So my billing system is completely depending on C and A. So consistency and availability is the most important factor that I should choose when I'm designing these kind of system. Let's suppose I'm building a chat application. Which kind of database I should choose? Chatting application.
AP.
Happy.
Why? Why AP?
Even there is a partition tolerance. So I want
Mhm.
my chat application to be, up and running.
Mhm.
Like some customers, I don't want my chat to be completely down.
Hmm.
I want my, some customer to continue their
Very
chat,
good.
and also,
Hmm.
yeah. So that means partition and availability will be going hand in hand. So even though for some it is down, for some it will be running.
Very good. And consistency, even if he's seeing my chat little bit, uh, there's a delay, I'm fine
Delayed,
with that.
no
But my
issue. No
WhatsApp
issue.
should be up and running. Okay.
Mm.
Correct.
I am a payment gateway. I am a Razor Pay.
Consistency and availability is
Consistency and availability. Why?
available because it's a payment gateway, so we cannot compromise with consistency
Mhm.
and availability. I mean, mm,
Okay.
it should be
Anyone else?
available.
Mhm. It should be available. CNA.
Yeah. Because he can able to pay. I mean that transaction will be without gateway. It will not complete, right?
Okay. Very good. If I am Amazon.com and I want to create my inventory system, let's suppose I am booking an order to buy a shoe. I'm booking an order to buy a shoe. Also, same time, another B person has already paid for that shoe. And this shoe is, I have only one pair of shoe in the stock. I have A user, B user. We like this shoe, S1. And before I was making
Yeah.
my comment, B already bought it, but my
Yeah.
transaction is still on the, which kind of database I will choose? This was the
See.
real-time question asked in one of the biggest company. So which
See,
will,
it has
So
to be
it will
consistent.
fall under CA,
Mhm.
and we have to use RDBMS, I think,
So CA, consistency, how consistency is playing role here?
because we have limited stock. Correct.
Okay, so my
So even though,
inventory table
yeah,
is updated and I have
Immediately
transaction
once
table.
transaction complete.
Very good. So now, do we understand why I was talking about A acid and
Yes.
CAP?
Got it.
Because when we are designing a big databases, when we are designing the systems for a business, don't jump into the conclusion right away. Try to give little bit understanding what kind of business is going to happen, what is the part of that. Ask these kind of questions, what you want to achieve, and based on that, you can go to the next level of your designing. And most of the time, all the big companies, if you go for the interviews and all, they try to understand all these things properly. And let's suppose you want to understand all these things in the depth, simply go to a site called Byte. They publish very, very good articles. Don't buy their subscription, but at least try to understand all these system related concepts. These system related concepts are going to make you different than the from other DBAs in the market. Okay, because end of the story, companies are looking these kind of knowledge in a very high level, and sometimes they try to understand what is your understanding about the system designing part. Basically, the thing whatever we did, ACID and CAP, is the part of database system designing. Okay, makes sense. And if you are not able to find their books online, you can go to archive.com. There you will find all their free books available. You can simply go to the archive.com, archive.org, and there you will type Byte Go PDFs and all, you will find it. Makes sense. They have released 2 books also. These books can be downloaded.
So according to the business requirement, we can able to choose that business best suitable database with costing.
With
I
costing
mean,
also.
yeah, like we build any, hardware for infrastructure, we consider all those things. According to the requirement, we can give the storage and CPU, memory, and
Everything.
budget. Yeah.
Budget. So the CAP and ACID is a very high level thing. Once you have these things finalized, you can go again with the licensing and all. Let's suppose Microsoft SQL Server is a paid product. So you might think like, why should I go for the paid product? I should choose some kind of open source technology. Okay. For Cassandra, let's suppose you can use Cassandra, or you can
Or
use
Apache.
Scala DB. So Scala DB is basically a layer on top of your Cassandra, and it makes it 50% faster than your traditional Cassandra. But this is paid version. Okay. Let's suppose I am using MySQL. MySQL have a lot of issues, right? On a certain level, I think that MySQL is not giving me that what I am trying to do. Let's suppose I want to alter big tables. So in MySQL, it is not possible. When we alter, either we can alter directly or we can use some Percona tools, right? PT tools and all. Let's suppose after a certain point, you decide that even PT tools is blocking your production or making your cluster slow, something like that. So you can think for TIDB. So these kind of transactions you have to do again and again. Go to the market, understand what is going on. Let's suppose you are choosing Postgre for your analytical load or data warehousing or something. After a certain time, you think that is not able to do it because I am looking for more faster database. Then you can choose ClickHouse. So these kind of thing you have to keep on doing as an exercise and try to understand what is going in the market, how they are fixing the issues. Another thing, whenever you are choosing any technology or anything, try to understand what open source communities are talking about it. Okay. So the best way to talk about all these open source things and all, there's a community called I forgot about it, but I'll find it. Okay.
KubeCon.
Cloud native. I will just give you that. It is there on my CNCF have very good cloud CNCF tech is on something like that. CNCF landscape. So what happens? All the technologies are getting distributed based on their usage. So this horizon, the CNCF landscape tells you which technology is used by companies and which is growing. Let's suppose if I want to go and see the databases. So according to CNCF landscape, my TIDB databases are very getting famous. Most of the people are using it, and then Vitess like that, then Cassandra, then SkylarDB, MySQL, Postgre. Getting my point? So it gives you very clear-cut statistics that how people are taking it in the market. Okay, so just make down this, bookmark this particular CNCF landscape, and whenever you want to see what is going good in the market, just go and see based on their category. Scheduling and orchestration. See, previously Jenkins was the top leader. Nowadays they have different softwares. Make sense what I am talking about here in this graph or in this website?
So according to the, industry more usage, this will update.
It updates, but this is not the ultimate information available, but at least you will get some guidance.
Yes, correct.
Okay. So these kind of things are very important. Just from the designing and system designing point of view, not from the database and all. It's a common knowledge that I'm just giving you. Okay, back to the main topic. Are we good? At least high level is clear. I don't want you to become the expert in one day, but at least you understand the CAP theorem. At least if someone will ask you what is CA, tell me Postgres CA or CP or CA, at least you will able to answer, right? After seeing this, that is my main intention, because my next class is so in the next classes, we are going to talk more on all these things, and I want you to be very clear with the wordings. Basically, when I say stats, these kind of examples should pop up in your mind. When I say parser, so that is the main intention. That's why I'm talking about all those things. Make sense? Everyone?
Yeah.
So if all are good, we don't have any question. Can we wind up the session for today? And I will put the recording after 1 hour or something.
Sure, sure.
Yes, thank you very much.
I hope
Thank you.
you like this all, whatever we have talked about so far.
Yes, Abhishek.
Yeah, very helpful.
Yeah, Abhishek, I wanted to ask, like, before the break, you given the exercise, right? So I was joined late. So that was covered, discussed.
That is answered by two people. Would you like to explain here, Prasanti and Jason?
Yes, please.
Yeah. Can you explain here, Prasanti or Jason? Anyone or both? I'm fine with that. Yeah, you can go ahead.
Yeah. So what I understood was, like, if there are, it depends upon the number of different sessions, like how many sessions are there, and depends upon that the number of backend process get initiated. Is that correct?
Correct. So it is basically depending on your connection. It is not depending on your specific transactions. I will add more twist. I will make it more complicated in the further classes when I will.
You mean
tell
5
you.
background process? The answer.
No, not 5 background process. Only 1 background process. That's what, right, Jason?
Okay. But
If there are
the multiple,
these are
multiple
related to
transaction will
threading,
initiate-
multi-threading.
Right. It's are interrelated with that. In future, we'll talk about that also. Multi-threading, single threading, coupled, decoupled, all those things. But very simple understanding. One session, one transaction, one session has connected to the database, one background process, and after that I run n number of transaction. It doesn't matter. Even if I run 5, I will get only one background process. Make sense, Prashant?
Yeah.
You mean with
Okay.
connection pooling or something?
No, without connection pooling. Let's not bring connection pooling now.
Yeah, that's
Connection
the
pooling we
application
will
part.
a connection pooling we will bring in the future sessions, and we'll try to understand which connection pooling has been used on which scenario. We are going to take these kind of examples again and again, chat system, payment gateway, and we'll try to understand which connection pooling is more appropriate and why, based on the Postgre architecture. Make sense? Which one?
Okay. Yeah.
Yes.
Everyone is clear, right? You are not going back with any doubt, right, inside your mind. You're crystal clear, right? At least whatever we have talked about. If there is a confusion, that confusion will become tree. From seed to plant, plant to tree. So this is the right time to talk about that. I'm fine. I can spend more time here. Okay. Any doubt? Because our next topics are going to be the basic, going to be the base for all the next. These kind of discussions are going to be our next topic base. Okay. So next topic is going to be the user management, schema management, and how we are handling the user role and schemas in the Postgre database. Okay, so that is going to be our next topic, which we are going to talk. And second thing, from the next topic onwards, I will go a little bit faster also because I have to cover multiple things. So next topic is going to be user management, search path, okay, and the catalogs, and also the extensions that we are going to talk about in the next coming 2 days. So make sure you are available. If you are not available, anyhow, I'll post the recordings. Everyone clear? Can we close the class? Yes or no?
Yeah, Abhishek. Thanks. Thanks a lot
Yes.
for your time.
Okay,
Thank
so
you.
let me give you your time back. We will see in the next session. Bye, everyone. Have a great weekend.
Thank you. Bye-bye.
Bye.
ठीक है रिव्यू स्टार्ट है एखादा तो घरी येऊन काम साफ करतो परत जाऊन जातो घरी मागणी त्याला बोलली आता आला नाही पण काय दिसते वाटतं मुलं आपल्या काय माहिती कोणतं दार
आने के बाद चंद्रपुर के ट्रांजिट ट्रीटमेंट सेंटर ले जाया गया जहां उसका इलाज चल रहा था। लेकिन वन विभाग ने बाड़ूगा के सबसे फेमस टाइगर्स में से एक छोटा मटका प्राणी उद्यान शिफ्ट कर दिया है। बताया गया है कि वहां उसका इलाज किया जाए। चंद्रपुर ट्रांजिट सेंटर में छोटा मटका की हालत में कुछ सुधार देखने को मिला है। मटका को घोड़ेवाड़ा शिफ्ट करने की बात सामने आते ही वन्य जीव प्रेमियों में एक चिंता की लहर दौड़ गई। वन्यजीव प्रेमी डरे हुए हैं और कह रहे हैं कि अगर छोटा मटका घोड़ेवाड़ा गया तो वहां उसकी दुनिया मिट गई। इसी वजह से उन्होंने किसी भी उपलब्ध माध्यम से इस मुद्दे पर आवाज उठानी शुरू कर दी है। मई इस महीने में छोटा मटका और शिक्षा विभाग ब्रह्मा की लड़ाई हुई जिसमें छोटा मटका पूरी तरह गायब किया। हालांकि छोटा मटका ने अपने इलाके को बचाने के लिए ब्रह्मा को मौत के घाट उतार दिया था, लेकिन भीषण लड़ाई आ गई थी। जो छोटा मटका की देखरेख कर रहे हैं उनका कहना है कि इस लड़ाई में छोटा मटका के 3 कैनाइन दांत निकल गए। शायद ही कभी दोबारा स्वीकार कर, और यही वजह है कि अब उसे गोरेवाड़ा घोषित किया जा रहा है। वही डेव राउत वर्तमान में गोरेवाड़ा सर देखो मेरा प्रयोग सफल होने वाला है। सामने से जंगली मुर्गी आ रही है, मुझे आज विश्वास नहीं हो रहा है। आ तो रही है सामने से, इसलिए मैं बताऊंगा जब भी। देखते हैं ये मेरी मुर्गी के सामने आ जाते हैं, और फिर मैंने टोकरी के अंदर सब मैं नजदीक आती है, क्या पता है आज ये तो बहुत ही मेरा प्रयोग तो लगभग लगभग आगे बढ़ रहा है। और देखते हैं इसमें क्या होता है। जंगली मुर्गी आ गई है, मैंने अपने घर की मुर्गी देखो दोस्तों, ये अंदर रखी हुई है, मेरी मुर्गी खड़ी हो गई। अगली बार एक अजनबी से मैं जंगली मुर्गी आगे आती है नहीं आती है, इसे कितने नजदीक दोस्तों मैं भी आपको लाइव दिखा रहा हूँ, तो देखते रहिए क्या होता है यहाँ। जंगली मुर्गा क्या आ जाता है, क्या दोस्तों जंगली मुर्गा क्या क्या है, देखिए मैं प्रतीक्षा कर रहा था ना, उससे आ गया है। अब देखिए मुर्गा भी आ गया है। अब देखते हैं आज कि प्रयोग जिसके लिए मैं आधे घंटे से वेट कर रहा था क्या होता है यहाँ पे। ये आगे हम उसे करते हैं, देखते हैं ये आज क्या करते हैं, लड़ाई करते हैं, इसको मारते हैं या इसके नजदीक आते हैं नहीं आते हैं, क्योंकि मैंने इसके अंदर रखी है अपनी मुर्गी, घर की मुर्गी। ये देखिए घर की मुर्गी मैंने हमारे यहाँ सोल्टी बोलते हैं, सोल्टी के अंदर डाला है, और सामने भी है जंगली मुर्गी। देखते हैं क्या होता है, इतना नजदीक इसके आते हैं, अब मैं उसको कल छिप जाता हूँ, देखते हैं क्या होता है। Man without money is a man without